All right, morning. My name is Vikram. It's my third time here at B-Sides. Proud to be back, and thanks to Jeff and Jonathan. I don't think they're in here. Can't see them. But thanks to the two of them having me back here again. Anyhow, today I'm going to be talking about securing the Internet of Things. This word or term really got a lot of buzz behind it. Sort of 2015 was kind of the big year. A lot of investment funding went into it. A lot of companies got started doing this stuff. But it's kind of like the early days of the internet. We don't really have a clue what we're really doing. We're hoping things work out and we get enough funding and so on to continue doing those cool kind of things. I'm one of the few people fortunate enough to be in a lab environment that I can play with a lot of stuff, and I don't have to worry too much about consequences, as long as I get to write some papers and so on. Those are hard to get to. But anyway, so what are we going to cover today? Not too much, but I'm going to start by defining what IoT is. A lot of people have a lot of different definitions. I'm going to use a standard one of my own in this talk. After that, we talk about a few industries and areas where IoT is very prevalent. It's growing very, very, very fast. I mean, that's why, all the buzz behind it. But it's penetrating a lot of different industries, so we want to take a look at what those are. Afterwards, to talk very briefly about some startups that are building IoT stuff. Then the current state of security in IoT, which I will say right now is very bad. But we'll get more into how bad exactly in a bit. And finally, I'll talk about my contributions to the area, where I come in and why I'm giving this talk and so on. All right. IoT recently has been feeling like kind of a nervous system to hardware and software. It's kind of like the old hardware abstraction layer, if you know from old kernel days, that used to be in. It's still in some places, it got taken out in some other distros, but it gives life to a lot of things that before were separated and just on their own. With that, the big deal with IoT is communication, particularly communication between devices and sensors. This has been a very, very, very big deal, and the reason is quite simple. Too many different devices do not connect to each other. They just, if you've used a printer, you know what I'm talking about. I mean, things just don't work out. And another thing has been that a lot of big consulting firms, Gartner being one of them, they sent out a report that around 20 million devices will be up in the cloud very shortly. These are 20 million that are going to be top performing, so you're talking about 4G, LTE, and maybe 5G and so on. These devices are online, and pretty much everything that's coming out now, I mean, even cars have LTE. Come on now. But anyway, having those facilities and capabilities also makes you vulnerable. You're going to see a lot of this theme repeat. Having more features is good, but you do not need an FTP server on a printer. That's just, come on. It's fine to have, but it's harder to secure. You have to always, a lot of people in this room are security researchers, you always have to move under the assumption that people will not configure devices the right way they're supposed to be. People want to use things out of the box. They want to get the easiest way to get something in and it work. Now, that's fine for most things, but if you have an FTP server running that has 1, 2, 3, 4 as password, you could have some very serious trouble. Incidentally, one of the vulnerabilities that Stuxnet, it's a huge, corporate espionage malware. It took advantage of one of the printer vulnerabilities, it's the Oatmeal. If you read, they have a comic that's printers are from hell. It's pretty funny if you've read it, but it's exactly what I'm talking about. Anyway, back to IoT stuff. In IoT, the holy grail and the main goal is that we're trying to establish a network. It could be a private, it could be a public network, but it is a network of connected devices. The core requirement, and probably the only requirement that we can satisfy at the moment, is that these devices have got to talk to each other. And we'll see shortly how they do. Devices, now a lot of different devices are converging in a sense that you can have, you look at mobile phones, this is a very good example. Samsung has their own stuff, TouchWiz and so on, but it can still load the same sort of apps that my Nexus would load, or the Sony Xperia phones or any of them would load. the infrastructure being different, but the software that runs out on top of it being about the same. That's kind of what IoT is going for, but at a much deeper level, much deeper as in system level. Devices need to be, talk, like I've been saying, they need to talk to each other, but more so, they need to be able to share data. That is a very, very difficult challenge to solve. I mean, you look at right here, on the left side, economists talking about, language of Internet of Things. Right side, that's Vice, and the bottom one is from another blog. But, all of them pointing out the same things. People saying that, can the internet really be unified that way? If you worked with firmwares and devices at, very sort of system level, you'll see how difficult it is for them to really talk and even share data. Message passing protocols, MPs and OpenMP and so on. Those are some of the common sophistications we use, in a lab setting. So if you're developing a server cluster farm or something, the way you would talk from between them is message passing. But that doesn't translate very well to sort of system level stuff. I've tried to work on some of this. So, taking known principles in message passing and converting them over to sort of system level Internet of Things devices. One simple solution to this stuff happens to be that you could use all the devices on some sort of the same backbone, if you will, the same protocols. That's probably not going to happen. Very low chance of it. Device manufacturers are very, very bad at talking to each other about this. Perfect example. I've been in the Linux community for a while. I was a developer, and just getting drivers to work, graphics drivers to work alone was a major pain, leave alone getting other new system level devices. It's very hard to get them happening. But there's progress. One of the ones, when Google does something, they generally do it right, at least as we're hoping for. One of the recent ones that came up during the last I.O. was this combination of something called Brillo and Weave. Weave is, I'm not sure if you guys can see the pictures very well, but basically the idea is that these devices are going to run Android, but not the stock Androids on your phone, but they're going to run a sort of a stripped down version, minimalistic version of Android, which will power all 5 or 6 of these devices that you want to put in the cloud. And because they're on the same infrastructure, you can hope that getting them to talk to each other, getting them to share data, take input, convert it into output, that's a lot easier to do given that they're on the same infrastructure. Nest is a company that is now under Google. They recently released something called Nest Weave. That's their own implementation, and basically it is one of the first home automation sort of ideas that use a common infrastructure. You can imagine one day you have the same device that, the same stuff that's powering your phone, maybe even your car and your home. Sort of the same seamless interface from one to another, and they can all communicate very well. Weave is only a small piece of the puzzle because Weave only lets you talk to things. That's not all the way there. The complete solution is Brillo. You guys might recall this slide from the Android or from Google I.O. When they did it. I just took it right from there. But it shows something very nicely. At the bottom level is hardware. Hardware could be different, but as long as it can be made to run Linux, you're making some progress. On top of it, which is the kernel. On top of the kernel basically manages the hardware to software interactions. On top of the kernel is HAL, the hardware abstraction layer. This is where some really neat stuff happens, because if you can take hardware that's similar enough, for example, USB, they're universal because most of them can operate on similar principles. If you can take hardware that's similar enough and abstract sort of the core object, and talking about object orientation, if you can do that, then you reach it's very easy to reach a consensus on devices being able to interact. Consensus is something I'll get into in a little bit and why it's important, but it is important that we can authenticate devices properly. That's probably one of the biggest security flaws in IoT, and we'll see it shortly. Now, what is happening on the other end in terms of hardware? You can see here it's very easy. On top of HAL, we can build everything. Most common Linux distributions either use HAL or something else that's similar to HAL to build a lot of connectivity and hardware services. We use them, if you have a Linux distribution on your computer. What is being done on the black box, which is hardware itself? Linux Foundation announced an initiative called Project Yocto. It's a common operating system for embedded devices. A lot of embedded devices are running it currently. A lot of them use it. Huge industry partners. I mean, Intel, a lot of the big ones are in it, contributing code to it. Again, the hope is still the same, that because we're using the same backbone, we can get these devices to work and talk to each other well enough. Go over really quick what it looks like. That looks like a nightmare, but it's actually a lot easier than that. I'm not going to go over the whole picture, but the point basically is you have, in Debian or in any package management system, you have something like apt-get. You just type that and type a package, and it installs it. Now, think of the similar principle, but applied to hardware and software drivers. You just have one script, a 10-line script that runs, and each of those 10 lines, it installs the exact sort of the same operating system, including drivers, on all 5 or 6 of your devices. That's kind of the idea behind Project Yocto. You can see on the right side, the same package feeds, basically the same repositories, are powering all these different flavors of Yocto that are available. And in the end, they all get compiled into the images that run on devices. If you've never tried Yocto in your small virtual machine or something, I highly recommend giving it a try. It is amazing. Just the simple amazing fact that there is something out there that can support 8 or 9 different devices. If you have a Raspberry Pi, that's a very good tutorial. There are several good tutorials on running Yocto on it. Basically, it gives you a very nice system-level access to the Raspberry Pi and let you do crazy things. You can do whatever you want with it. Going back to something I said earlier, the very simple fact that this can happen, that alone is amazing. Because historically, it's been incredibly hard to get device manufacturers to agree on building something like this to begin with. All right, so been talking about IoT sort of from the system level approach. I want to talk from the other angle being from the user end. IoT has been around in way too many places now, but what are some of the prominent applications? I want to talk in this section about some of the common ones that are around. Here's a brief summary of the applications that we see most commonly around. Manufacturing, they're mostly focusing on supply side. One of the big trouble that a lot of manufacturing, at least the supply side chain people have had, part of the reason a lot of them turned to Yammer and so on was keeping track of inventory. Stuff coming in, they can't keep track of it in time, and what's needed, what's in transit, and so on. They're really trying to get big on IoT and RFID chips and so on to make sure that the supply side and manufacturing process goes as smoothly as possible. They don't waste a lot of money on it. Healthcare, big one, something that I also had spent a little bit of time on. Electronic health records. Any of you have Fitbit? Any of those devices, are, yeah, thank you. Yeah, those devices, are they're constructed in a similar sense. A Fitbit alone is not IoT, it's a component of it, because that Fitbit connecting to your laptop, connecting to your phone, going to the cloud, one day you can imagine that there will be more sensitive Fitbits made that can track heart rate more reliably. You could have that data being piped directly to your physician, or as some sort of a monitoring server which will notify your physician in case your heart rate goes too high up. That's the hope, at least. Retail, mostly these guys are sort of the front end of the supply side. They're mostly using it for tracking and so on as well. Similar ideas, but here's something very interesting that comes in retail, and I'll talk about it later on in more detail. iBeacons, if you guys have played with them, there are some very cool principles you can apply from using iBeacons as information, sort of almost advertising tools. You walk around in a store, your phone gets a notification, you pull it out, check what's going on, like, oh wow, so that's what's going on here. They could tell you about a sale that's not there. Only if you have your phone you could do it. You could make a lot of augmented reality games and so on, even from that. That's part of the thing that they're going for, at least. Security. Biometrics is becoming a huge deal in IoT. So using your fingerprint to unlock device, and not only do that, but also authenticate it to the rest of the network. So in an enterprise environment, you're talking about something that could connect right away and open you up to, it could also authenticate your email and so on and so forth, all 4 or 5 different things through your fingerprinting. Finally, transportation. This is a big one because it's becoming very, very practical. Google's doing self-driving cars. Apple is participating in it. They're putting a lot of money in it, and we don't know what's going to come out yet. Uber and Lyft are trying, they're trying to build automated cars that, or self-driving cars. GM and just partnered with Lyft, and they're rolling out their first sort of batch of these in 2018, I believe. That's going to be exciting because you can imagine, not only self-driving cars are going to be amazing, but the fact that you could also have the same sort of ride sharing and all those features built into the device. That would probably be a pretty exciting thing to do. Let's go into a few of these areas in sort of more detail and see how they work out. I briefly talked about this whole idea earlier of healthcare being of importance, especially because a lot of money is going into the area. There are three sort of these components in a triangle: the payers, which are people who actually are paying for the money for the treatments; the providers, that's your insurance plans or so on; and the patients who are actually getting the treatment. Very often these three are not in sync. To give you an idea of how bad it is, $3 trillion are spent each year in healthcare, and about $1 trillion of it is completely wasted. So there's a lot of incentive here to save any money from that trillion by incorporating new technologies, experimental technologies like IoT. Sensors are becoming very, very a big deal. Like I said, Fitbit being an example. Pebble, they released a health step tracking and health API. Apple Watch has a couple of fitness initiatives too. Sensors are becoming important because these devices do one thing very, very well, which is track what they're given to do. And if you can get them to talk in a smart way, you might have something very interesting going on where you can sort of automate your own life or your own health in that manner. So you can imagine sensors providing data that can be accessed easily, or through like a REST API or something, and then an application building on top of it where you can do more fun things with it. That's kind of where healthcare is going. At least it seems to be that way. We talked about iBeacons, talked about them earlier. The main idea here, again, being that you can use them in a lot of ways that you couldn't otherwise. For example, proximity marketing. I saw an application of this happen. It's very, very cool. It was in the lab, so it wasn't actually in the environment outside. What was interesting was you could see, you walked around with it, and if you were in close enough to it, you could see an ad or something, or a sale or something like that of the item being on the shelf. And it was amazing was all I needed to do was walk past it, and I got a notification on my phone. That's pretty amazing. Instead of having to look around to each of the, through the shelves or through flyers or anything, you just get the notification automatically, which I think is actually a pretty cool thing. Context is also a big deal. So based on what you've been shopping, it could recommend more things. It's kind of like an Amazon, you might also like thing where you can buy more things right off of based on your recommendation. And that gives a lot of power to the stores or the people who are putting the items up, because they simply need to program the iBeacon to take some information and provide it to your phone. That whole process is very simple and straightforward. The cloud then actually does the processing of making recommendations and so on. But again, seamless and very, very easy, because you don't even have to take your phone after that. This has been one of the largest sort of drivers of IoT, which is home automation. You guys all know of Nest and the automated control light bulbs, and more importantly, Belkins, which you can control. The coolest thing about them is they don't aim to change what's already in place. They only aim to change how it's accessed. Now, what I mean by that is, you can imagine your coffee maker doesn't have internet Wi-Fi on it. It shouldn't. Now, if you can't, you can either just build a new coffee maker that has Wi-Fi, or you could build something that has Wi-Fi, but it turns the coffee maker on and off. The reality here is that instead of phasing out old devices and making smart devices all over again, you could just control access to power. That's one of the things that that Belkin's done really big on. You can control the access to power, and that matters a whole lot more. The next thing, and this is actually getting maybe perhaps more serious. The reason here being that there is a lot of government money going in here, and this is infrastructure. Anybody here taking the public bus? I took the public bus for 4 or 5 years. It's terrible, right? Yeah, thank you for agreeing. A lot of the problem just comes out from not only miscommunication, but also not knowing where the bus is, not knowing what anything is happening. The whole idea of smart infrastructure is to keep the people using it and the people providing it on the same page. The whole idea here is if you can make that communication faster and seamless, people will be more happy, people will want to use your service more. I think a pretty reasonable assumption is if I know when my bus is coming, I don't have to wait outside for 2 hours, I'll be pretty happy, right? That's how it used to happen. Not only is this kind of stuff becoming more prevalent, in Japan it's kind of been kind of the commonality from what I heard. I've never actually been there, I'd like to go, but one of the coolest things they've done is build these IoT sensors that work along with Raspberry Pis. And they just leave them in sort of a plot of land somewhere. And these things can tweet if there's an earthquake happening. So they can sense seismic motion, and they can tweet if an earthquake is forming or even close to getting to dangerous levels. And you can see the public Twitter feed anywhere at any time. I think that's a pretty neat application. Nobody's thought of that kind of stuff. People have also done some neat stuff where you have a sensor that's connected to a plant. It's actually in the soil. And then it sends you a message saying, I need water because the plant, the soil's dried out and stuff. That kind of stuff is pretty neat. That's also where hobbyists sort of come in. You have to realize everybody who's interested in IoT has to come in from an angle. So a lot of people come in from the healthcare angle, people like me who are academics. Government is coming in from the infrastructure angle. Hobbyists are coming in from iBeacons or building these sort of DIY home devices, which all of them are very neat. And this is one of the best things that's happening. They're teaching people how to code. A lot of people who know how to program well enough don't understand the basics of networking, not at a deep level. But these things are sort of forcing them to learn, because if they're not, then there could be other trouble. Now, a lot of the things I talked about so far were small players. Let's talk about big efforts, and particularly I'm going to focus on Watson, Oracle, and Microsoft, and what they've done, because what they're doing is probably going to change the game forever. Who saw Watson at the Jeopardy game and so on? Everybody, right? Probably. Yeah, it was a huge deal. Watson also is building cognitive services. There was a recent trend by them, what they call cognitive services platform, which is the idea that you can offer machine learning or deep learning tasks as a service. You can drag and drop them, attach them in sort of a flow chart, and all you need to do is provide data, and Watson will give you the output. What I listed up here are just some of the services available, but you can imagine just dragging and dropping 4 or 5 of them to build a pretty convincing network, pretty convincing at least task runner. They're building out this new entire infrastructure actually with 38 new services specifically for sensors. They're going to work very well with some of the Intel supported devices actually. It's going to come out, I think, mid-2016, unless it already has. I'm not too sure at the moment. But basically the idea there being that Watson is going to be able to power a whole new world of devices. And because the reason Watson matters so much is because they have the technical sort of, not only the resources, but the expertise to do it. They have enough servers, they have enough all of that what is needed to power a very, very good private network. And obviously they're going to charge you a fortune for it. But that aside, the fact that they can do it very convincingly, that matters because they're going to push it forward. The fact that they have enough resources to make all those things happen is going to ultimately push IoT further down, because dragging and dropping, you don't need a lot of time to put together sort of a first prototype. On the enterprise side is Oracle. Again, don't worry, I'm not going to go through the whole chart. But what matters is again, something convincing that they've done, which is actually at the very bottom. Java powers a lot of devices, even some embedded devices and so on. Some of that's being phased out, but in any case, it powers enough devices. Oracle, what they're now trying to do is push out separate set of API that can allow things that are powered on by their own devices to collect all that data, pull it back, process it in the cloud, and then finally let it do whatever you want to do in your organization. What's important is this whole team might become more universal now. I've been through my talk about halfway. The gather, stream, manage, and action. People need to collect more and more data to get actionable insights, the big word for it. Basically meaning making a decision based on the data that's available. Oracle, especially powered, if you use PeopleSoft or UCF's stuff, a lot of it's powered by Oracle. A lot of that information could be pulled in and processed in the proper way to give more actionable insights into the people using it. That's kind of what Oracle is banking all this on. And finally, last, Microsoft. They had the coolest looking graphic. No, I'm kidding. Microsoft's main appeal has been with Azure platform that they're using to power Internet of Things. The best thing about Azure is the visibility you get in terms of not only metrics, but the data itself. Azure's been exceptionally well in providing a lot of new ways or angles to look at the same data that you gathered. That's really, I think, what's been powering them. That's the big difference between Microsoft and the other competitors so far. When you use their devices, unfortunately, the limitation on their devices is they don't have a huge amount of different devices that are powered by the Windows platform. Windows Phone is doing so-so, it's not doing great. Besides that, the server and the desktop environment are about it. A lot of people are switching away from, hosting Microsoft servers or even embedded devices away to other things. So they don't have a lot of leverage in the area, but what they do have is an amazing platform for visualization and data analytics. That's why a lot of people are using them. Finally, get to sort of the meat of the talk, which is the current security. Now, there are issues with it, both good and bad, but you got to realize this is very early days. I mean, think of all the progress that's been made in Internet of Things right now, and we're still at day zero. We haven't even started yet. There's a lot of room for improvement, and that being said, let's tear down IoT and see what's going on right now. People have no idea how to secure their devices at the moment. There aren't any standard protocols simply because people don't know how many new devices people are going to come up with. More importantly, then this is kind of the second factor is kind of the sad thing, which is people think that we can compress years and years of security very fast and very, very rapidly. Just because some security policies worked in one environment, they think it will also translate very easily to it. I will personally say that it's been very hard to translate even small policies over. And finally, no one solution is going to be able to secure it. This is something a lot of experts in the area agreed. You cannot just go find one solution that will secure all 500 devices connected to your private network. Just not going to happen. You're going to need device-level security as opposed to cloud-level security. And we'll get to that. Let's talk real quickly about what are some of the challenges we're facing. Number one, probably the biggest one, too much data being collected. Now, it makes sense. This is the whole purpose of IoT. You're supposed to collect more data. But the problem is it's becoming too much to where we don't even know what the streams of data inputting are. If you don't know where the stream is, you can't secure it as well, or as easily. Another thing, because we don't know all the use cases, people can make whatever they want to make with IoT stuff. They can use the hardware, the software, come up with new software. There's no sort of centralized repository where they all can be managed. For example, like Ruby gems or something. The centralized place, everybody knows that's where to go look for them. Here, completely out in the wild. It's hard to secure something where you don't even know the parameters or what goes around it. Lastly, the more devices you connect, the problem is the more security flaws you're opening up. Every device, if it has one flaw and you connected 500 devices, you're probably going to have 500 flaws. Given they're all different, that's probably not going to happen. But nonetheless, the point is, if you connect a lot of different devices, all on their own sort of infrastructure that are different from others, you're also going to have trouble managing each of those security flaws, which becomes exponentially difficult to manage. Very, very hard to do. If you have hardware or firmware issues or security issues that go that far deep, God help you at that point. I mean, it's very hard to manage software level issues, leave alone something as problematic as a firmware security issue. The other problem is a lot of people aren't understanding how to define access level. If you have predefined environments that can control how the access works, that's one thing. But if you're at a stage where you don't have any idea how the access level is going to be managed for users connecting to it, you can't control that. I actually worked on access level control, wrote a grant to Google, which unfortunately didn't get funded. But I worked on it anyway later on. The part of the grant was dealing with authentication, especially user-level authentication, and how you're going to manage it. And I'll talk about some of that work later on. And lastly, maintenance of the devices that are connected. A lot of people don't like to update their computers, leave alone update firmwares or things on their router, and then you go on to sensors and so on. Nobody's going to update them. Now the issue is, how do you still manage to keep those devices free from vulnerabilities if you cannot manage even the most basic update procedures? They're going to be very hard. And I'll show you what happens when people don't manage them. So one thing that came out very recently was huge, which is this search engine called Shodan, which actually gives you access to, it's for free, you might even look it up. You can get access to cameras that are out there and view all the unprotected streams like you're doing a Google search. This was huge, and it made people not only think about how bad the security is, even made some people close down their private clouds entirely. I mean, it was so bad that, you could see that, some of them were actually incriminating and so on. But anyway, that aside, the real story here is that some of these devices, the people, again, the users cannot be held completely accountable. A shopkeeper is not going to spend 10 hours making sure the camera and the way the camera connects to the recording device and so on are secured with AES and a 13-character passphrase. Just not going to happen. We need to find better mechanisms on our own, because if people aren't going to do it and this stuff keeps happening, some of this could spill over into very serious matters, as it happened in some healthcare, in some hospitals, and we'll talk about that in a little bit. HP released a report under their Fortify on Demand initiative on the Internet of Things, and this is what the report said. About 25 vulnerabilities per device, and they only examined, I think, 15 or 20 of those devices. And some of the common points I talk about here, the one I want to focus on particularly is a lack of transport encryption. Basically what that means is two devices that are talking to each other aren't even on a secure layer like SSL or HTTPS or anything. They're talking completely in open. Anybody could intercept. Again, if you think deeply about who really should fix this, not the developers or the consumers. The developers cannot secure everything. Mistakes happen. People don't, if you think about budget and project allocations, not everybody's going to allocate every security feature in every project. What we need is something fundamentally different, and more importantly, something ingrained that can come from bottom up as you design devices. Oh, and obviously, software protection. Nobody updates their stuff. My laptop is not updated, by the way. No, I'm just kidding. I updated yesterday before the talk. This was another big thing actually that came out recently with Nissan. Their Nissan Leaf. This guy, anybody follow Troy Hunt on the blog? Okay, you guys probably already seen this then. Yeah, a lot of the stuff, what happened was basically, they were talking about vehicle control, and they had an application, a mobile application to do it. A lot of the data about the vehicle, the point of the app was to get a lot of good data on how your car works, it runs, and so on, and even other features about it. I'm not going to get too deep into it. The problem of it came out to be everything about the car was accessible through REST APIs. Even use a secret key, nothing. It was very straightforward, accessible, and the column on the right shows just some of them. It turns out you could use some of these variables or some of the results that came out here, plug them in back into the REST APIs and get even deeper access. The name of the person, you could turn the car on and off remotely. They pulled off the app, I think, right away after this came out, which is very good on them because they, quickly saved the world. But, damage already been done. This is just one example of something at a massive scale that happens if you don't have not only the right policies, but even the sort of the design mindset on how to control IoT. And again, you cannot blame them for it. This is all far too new for everybody, including security people like me and Troy Hunt, who pwned it. finally, get to where I come into this talk and what my contribution was. I wanted to save the world, protect all these devices, but that didn't happen soon enough. I tried to take a different angle to it, which was, as I mentioned earlier, try to translate security policies and so on that have already been in place for years in big tools and big companies and bring them down to sort of these normal play devices. First thing I worked on, which happened to actually give some positive results, was make every connection count for money. So microtransactions, by implementing smart contracts and microtransactions, what you really allow to do is two devices cannot talk to each other unless they either pay up in terms of resources or actual money, Bitcoin, anything like that. The point of it being you could connect two devices very securely this way, because a third device trying to access it wouldn't, one, either have the payment system set up. If it does, it wouldn't be able to that easily get into your payment stuff. If an external device or external hacker can get that easily into your payment system, you have other problems than IoT. But that aside, adding payments makes it very unlikely for people to sort of want to hijack and connect. The same issue why, email spam, that was one of the things about eliminating spam was if you had to pay a fee for every email. One of the exciting applications in Bitcoin particularly has been if you attach a small microtransaction to every email you send, you will eliminate spam, because for spammers who send 10 million emails a day, that transaction would add up to far too much real money. They just wouldn't do it. The cost benefit, the cost of sending it far outweighs the benefit they'll get, because nobody clicks on those links from Nigerian princes these days. The smart contracts are nice because they're autonomous and self-executing. But what that comes down to is you could have two devices completely without a person monitoring them connect to each other, manage each other, and even check up on what the status is. That could become powerful because if you have something like a JSON leak, like with the car stuff we had earlier, if there was a sensor monitoring the outflow of that information, they could have detected it was information coming out that somebody was accessing. Even if you can't stop it, knowing that it happens, that alone is a big deal. And this was the second idea I worked on, which was detecting, there can be a whole magnitude of threats that come in either from inside or outside. For IoT, instead of looking and preventing threats from the outside, what is probably more reliable to do, arguably so what's more reliable, is to monitor once your device has been compromised, how it homes back. That's the whole idea behind extrusion detection. How is it that your devices are connecting from your software, your system, outside to the command and control servers? If you can, instead of monitoring for every threat that's outside, a better policy is to monitor your own devices and every threat that penetrates through. The idea here being, if you can control how your devices interact from inside out, you might be able to eliminate completely how that connection works. So the point of it being, if you could manage how exactly your devices are transmitting data outside, you could probably completely stop it. One of the things that VeriSign found in the later half of 2015 was that DDoS activity had been some of the highest that it ever had been in a very, very long time. They do a 4 or 5 year study. They found it was way, way, way higher than it had ever been before. And one of the ways that you could really bring down a lot of it was if you could control your own devices well enough. If you had policies in place, instead of protecting from DDoS from the outside, for DDoS you can't really protect too much. What you can do is mitigate some of the damage from the inside out so that you can isolate the system and make sure that your devices are protected well enough. And finally, the thing I was talking about earlier, which is device and role management. This is something that's actually very, very simple. A lot of security tools implemented, like SE Linux and so on, but a lot of the tools aren't actually doing or applicable to system level security. The point of it being, if you can manage and authenticate a device, if you know exactly what's connecting to your network, you might be able to stop some devices from connecting to it. This could also mean malicious sensors. You can imagine it's not too far-fetched to think somebody would design a sensor with some software on it that's supposed to, instead of sending in data, actually just taking data. Or worse off is providing wrong data. That happened, as I mentioned earlier, in the case of Stuxnet, where the data being provided from the nuclear centrifuges was all completely wrong. So the engineers thought the centrifuges were totally fine, when in reality they were breaking down. So that, there you have a risk of very serious espionage. I'm giving a very extreme example. You're not going to find IoT iBeacons in a nuclear reactor, okay? But the point of it being that, if you have a better idea of who's connecting to your devices, you could probably do a very good job at maintaining them. System policies are effective, but to a certain end. What really matters is device-based role security. Not everybody should have access to everything in an enterprise environment. You should limit the access, and not only limit the access, but more importantly, make it so that their roles define how exactly they can connect and authenticate to more services. If you can have a very clear idea of that happening, I think you'll really be making strides towards securing these new internet devices. And with that, I hope I saved the world. Not really. It's funny. In security, often you're fighting a losing battle. You make things you hope they work, and often they don't. And then because the attackers will come up with more sophisticated, or something you missed entirely. Sometimes you work on a thing hoping that it would work out very fast and safely. It just completely blows out of the window. But yeah, thank you so much for coming by, and that was all. If anyone likes to ask any questions, please either come up or just say it from there. I'd be happy to answer. Thank you.